the situation here is we have a circle of radius r. Now, this picture originally started with just this, so let's focus here, and then we'll see how the different parts of the different labels and the different vectors and so forth came about. So the circle has radius r, and we have the vector r from the origin to a point. So here's a point, and it moves at constant angular velocity omega around the circle. Theta is the angle from the positive x-axis. So we ask the question, first of all, let's assume now that theta of 0 equals 0. At time 0, the angle is 0, simply meaning that the point starts here, where the angle is 0. The r vector will be here at angle 0. The point will start here. So my question is, what is the velocity? Now, you see we've got the velocity vector here. We know that since this point is moving around a circle, the velocity vector is going to be tangent to the circle. So we have a certain velocity vector tangent to the circle. And I ask, what is v when the angular position is theta? Okay, so again, points moving at angular velocity r theta. When we have angle theta, what's the velocity vector? And we've got an arrow over this, so what's the vector velocity? If you don't understand this, you should pause and reconstruct it. If you were in class, you should still pause and reconstruct this. Well, the magnitude of the vector is just the speed of the particle, and that's r omega. Now, everything that we're doing here was done about a month ago in videos, so I won't say everything, but this whole model was done about a month ago in videos. You might want to review those. Most of you are taking multivariable calculus or vector calculus and dynamics, engineering dynamics. And all this is part of those courses as well. So all the techniques we're using here should be common to all three courses. Now, so V is r omega. And we understand that by understanding that omega means the angle per unit of time. And if you multiply r by the angle, you get the distance along the arc. We conclude that the velocity is r omega. Okay? Now, my question is, what is v? And it is, what is the magnitude of v is r omega. To specify v, we need to specify its magnitude as well as its angle. And what's the angle of v when the angular position is theta? Well, you should think that through before you skip to the answer. But the direction of v is 90 degrees plus theta. And I'm going to call that alpha. So on this picture, we have the same stuff. Here's the point, here's the velocity vector v, and here's angle alpha. And alpha is theta plus 90 degrees. And why is that? Well, if we look up here, this dotted line is along the direction of r, the r vector, and it makes angle theta with the direction, with the I direction. Okay, so the I direction is here, and there's your angle theta. And then because the tangent to a circle is perpendicular to a radial line, we have an angle 90 degrees between the direction of r and the velocity vector, meaning that the angle of the velocity vector with the I vector is theta plus 90 degrees. 90 degrees plus theta, we call that alpha. Now, what then is the vector v? Okay, questions asked here. V equals what times I plus what times j? The answer's on the board, but you should think through it. Okay, well, in the simplest possible terms, a vector with magnitude r omega and making angle 90 degrees plus theta with the I direction, the positive x direction, the vector is going to be magnitude times the cosine of theta times I plus magnitude times the sine of theta times j. Just the most basic property of a vector of given magnitude and angle. So the magnitude is r omega, the angle is 90 degrees plus theta. We get r omega cosine, okay, we used alpha for this angle. I'm going to just use alpha to make it as simple as possible. We'll use the 90 degrees plus theta in a minute. We'll just substitute that for alpha. But if the magnitude is r omega and the angle is alpha, then the vector is magnitude times the cosine of the angle times I, plus magnitude times the sine of the angle times j. And magnitude is r omega, alpha is the angle, so here it is. And of course, since alpha is 90 degrees plus theta, we just used alpha to give the angle an easy name for a minute. It's r omega cosine 90 degrees plus theta I, and then sine 90 degrees plus theta j, etc. Now, you should know that the cosine of 90 degrees plus theta is the negative sine of theta, and that the sine of 90 degrees plus theta is the cosine of theta. If you don't know that, you should stop and work it out on paper. If you have to look up how these things are related, you really want to know this. This is not something that you want to go through an engineering program not having it at the tips of your fingertips, not having it at your fingertips. So anyhow, here's your velocity vector. So we can come over here, add that information to our picture. The next question I pose is, and I don't think I've written it on the board, so I was kind of hesitating. It's been a couple hours since we did this. Oh yeah, here we go. What's the x component of the velocity vector, and what's the x component of the r vector? And I don't know that I'm aimed quite low enough to get that. You should answer those questions. What's the x component of the velocity vector? What's the x component of the r vector? Now, you should pause and think that through, but it should be pretty clear that the x component of the r vector is going to be r cosine theta, and the y component is going to be r sine theta. The vector has magnitude r and makes angle theta with the positive x-axis, so it follows immediately that its x component is r cosine theta times I, and if we need it, the y component is r sine theta times j. What are the x and y components of the velocity vector? Well, Vx is just r omega cosine alpha times I, and what's the cosine of alpha? Alpha being 90 degrees plus theta, the cosine of alpha is the negative sine of theta. So the Vx, the x component of the velocity vector, which I've sketched here, moving to the left, just the projection on the I direction of the V vector, is negative r omega sine theta. Of course, we can go back to what we obtained for the velocity vector, and we can easily see that the I component is the x component of the vector, r omega, negative r omega sine theta. So here it is again. So this all follows from the most basic properties of vectors. Now, the next question we want to look at is what's the magnitude and direction of the acceleration vector A? And that's something you should ponder, and we'll get to it in the next video clip.